Thanks everyone for gathering. We have Rishabh talking next on retrievers, rankers, and multi-objective balancers. Really excited for this talk. Like the terminology that comes with MLOps always blows my mind, and it just kind of reminds me of a Slack message I read when we released our latest version of Core recently. One member of our team, Sheriff, who might be here, says that Core 2.8.5 RC is built, and his colleague said, "I'll also take it for a spin with some of the Chaos Monkey control plane tests plus load." So on that note, I'll hand over to Rishabh to talk about retrievers, rankers, and multi-objective balancers. Thank you.
Awesome, thank you so much. First of all, kudos to Sheldon. I've been a very happy user. In the previous company I was at, Sharechat, we had 50 million daily active users in the short video app, and we transitioned from ex-Sourcegraph to Sheldon, and we've been a very happy customer. And today afternoon, I cross-checked with my previous engineers that, hey, you're still using it? They said, yes, we're still using it, so we're still a happy customer. Cool, so my name is Rishabh. We're gonna talk about a few different stuff. I have 100 slides in here, and we have like 30 minutes. So we're going to be very rushed, but we're going to talk about, I'm going to slow down at the places where I think we should have a takeaway message. And I'm going to summarize along the way as we go. So quick show of hands, how many of you have worked on like any B2C, I mean, how many of you work with like B2C companies right now? Nice. Great. So today we're going to slightly talk about how companies like these have evolved to do recommendations. And how many of you are working with like some LLM-based product today? Not using it, like working with. Great. So again, similar to that, we're going to talk about how people are thinking about context, and especially RAG, like retrieval augmented generation, RAG systems, context engines, and then I'm going to try to bring it together. That, hey, we've done 20 years worth of work in search and recommendations, and why isn't the RAG community looking at it and like literally just copying and stealing? So we try to bridge the two together. And towards the end, I'm going to try to make a point on like, hey, these systems evolve over a period of time. It takes a lot of time. And the MLOps community probably should be thinking around how do you support the tools as the different companies mature their journeys, right? Both from the databases, from the deployment, and all the other perspectives. So a quick background, I recently, my last year at Sourcegraph was a couple of weeks ago. And before that, I worked at like consumer ML and enterprise ML in terms of topics. I spent the last 10 years researching complex task evaluations, multi-objective machine learning, and I did my PhD here at UCL, like close by. A lot of joint work with a lot of ex-colleagues at Spotify, Netflix, and a bunch of other places. So, I mean, these are like really approximate times. I want to stick to them, but probably I won't be able to. We're going to spend some time just talking about Rex's formulations. I'm going to talk about like what an early stage company would be doing today to have a recommendation model, right? They're going to be looking at like embedding-based retrievers. Once they mature this stack, they're going to start talking about two-stage ranking, and then they're going to start focusing on what should be the optimization objective be, thinking about reward models, thinking about multi-objective, and then going about systems overall and not just a model, right? So I think like we're going to look at like how a company like Spotify, Netflix, TikTok, Reels, all of these have matured in the last 10 years, and why a company today will also kind of take time to mature their stack across these dimensions. We're going to then borrow the same terminology, same thinking, and then apply quickly to RAG. I'm going to draw some parallels, and towards the end, I'm going to say that, hey, I mean, this is not it. I mean, these type of evolutions, we're starting to see in a lot of different problems like ad load balancing, like, I mean, if you're giving some discounts to your customers, or like evaluation measurement, all of these. And we're going to wrap up. Cool, so let's start with evolution of Rexes. So again, we're going to talk about a bunch of these evolutions. This slide is going to pop up every few slides, and whenever it pops up, we're like, hey, we've matured from the previous stage to the next. So that's going to be the flow. So again, Spotify, right? I mean, approximately how many music tracks on Spotify? Quick, short of the number. 10 million now.
Over 65 million or something.
Over 65 is correct, but anything over 10 million is also correct.
6,000 new tracks per day.
That's it. I mean, new tracks per day, I don't remember. I have the answer for. It's close to 100 million. 100 million tracks, 120 million tracks on Spotify. How many movies on Netflix? Approximately, just rough estimates. Anybody? A million? That's large. I need an answer from the back. A million is the same answer as well. 10 million is even larger. Close to 100K, 150K, and even if you combine, because the videos are harder. Short videos are easy to generate. A lot of videos are harder to generate. And then if you look at short videos, look, I mean, I did post a photo of a buffalo on my Instagram, so that's the reason why you should follow me. Probably not. But like, if you look at the short video catalog, any numbers, guesses over here? 500, yeah, I mean, sure. I mean, the point over here is short videos are like 100 million a month. And this is a big problem, right? I mean, when I look at Netflix, it's like 50,000, 100,000 movies overall, right? My recommendation space is like 100K items. When I look at Spotify, my recommendation is like, I mean, this is dated. Like, this is like 1 year old. So like 120, like replace 80 by 100, you get the approximate numbers. But music is like 100 million music tracks. In like 300 years of humans creating digital music and storing them digitally, right? That's us as a human species. But then when you look at TikTok or Reels or Sharechat, these platforms create 100 million items a month. So the catalog is insane, right? We're talking about like the previous database talk, talking about real time. This is what real time is. Content dies like within a few hours of its creation. So the catalog is big, and that means the scope for discovery. I mean, I would have watched maybe like 100, 500 movies. I mean, the short videos getting 100 million, I'm gonna only watch, I shouldn't be watching a lot because I should be working on my startup. But I do watch, and then I'm watching like maybe like 50 short videos. So the scope for discovery is great. The user investment on each item is different, because if a movie is bad, you're gonna waste 120 minutes, but if a short video is bad, you're only gonna waste 15 seconds. But more importantly, the shorts are success. If you stay on my platform for 5 minutes, if I'm a short video app, then I get to show you 20 items. And if you're unhappy with those 5 items at the start, it's fine, because I can recover from it, right? So the amount of real-time machine learning I get to do at a short video app is tremendously more. I have a lot more leverage, but correspondingly, the MLOps needed is a lot more real-time systems. The embedding should be real-time, the feature store should be real-time, everything should be real-time. And that's why like TikTok and other short video apps adapt on the fly. You start liking football videos, it starts showing you more of those, right? So the shots of success is great. The feedback loop is a lot more faster. The content reconsumption, I'm probably not going to reconsume short videos, but I do reconsume a lot of like content on music, right? Maybe some podcasts, but a lot of music are mine. I go to these songs every now and then. So my point is, there's a lot of problems around recommendations across different stacks, across different products, and we're not even talking about fintech products here, right? I'm just talking about like media consumption across different verticals. So there's going to be a ton of other problems and a ton of other heterogeneities around as well. And this is the recommendation problem, right? What to show to users, right? Like, would you like this? Would you like that or not, right? That's the recommendation problem. That's the background. Now let's talk about like, okay, you work in a company which has to build a recommendation product. What would you do? The simplest approach today is you're going to have an embedding-based retriever. So embedding-based retriever says that, hey, I have items. My items could be products, it could be fashion, it could be music tracks, it could be anything, right? So if I have products, each product is an item, and I want to embed these items. Embedding is like, I'll generate a vector for this item, I'll also have a vector for the user, I'll do a dot product, and then sort by that, pick up the top key, right? So again, first I'll decide an embedding model. Embedding model could be, most of these models are on Hugging Face. I can pick up any pre-trained model, like sentence transformer or anything. Or I can say, no, I'm going to fine-tune the model. I mean, I can pick up a pre-trained model, but then I'm going to fine-tune it on my data and bring items closer together, move them apart, train it. Or I can learn my own embedding. So at Spotify, this is 2018. We learned our own embedding models, at least from 2018 to 2021. We were retraining embeddings every 24 hours at what, 150 million items, right? So each of these get retrained every hour, every day. Similarly, at my previous startup, like Sharechat, we used to update embeddings every few minutes. So again, the embeddings get updated, and then you start using it, right? So you get the embeddings with the end user, you do a dot product, pick up the top case, show to the user. Now you have a recommendation product. At the end of the day, users see a personalized recommendation. Now the problem here is there's no feedback loop. I picked these top 5 to you and showed to you, you skipped all 5 of them, you abandoned, you never came back. If you come back tomorrow, I'm going to repeat the same mistake. Why? Because the embedding is the same. I'm not, again, right? If I'm not having any fine-tuning between today and tomorrow, if I'm not doing any learning, then there's no feedback loop, so there's no learning happening. So these systems don't consume feedback from the user, so the personalization is like really limited. So again, if you're not doing embeddings, you're doing some other things, right? You're doing you can generate embeddings using neural collaborative filtering. This is like extended form of matrix factorization. You get the user tower, you get the item tower, you learn the dot product. This signal over here is like whether you liked it or not, whether you purchased it or not, whether you skipped it or not, whether you downloaded it or not. You can train these embeddings in different ways. Another thing which has been really large-scale deployment are factorization machines. So again, not going to talk in detail about this. Similar to embedding neural models, you can train a factorization machine model, which says that, hey, I'm going to learn latent factors of items and users. I'm going to have an interaction between these as well. And then these parameters get spit out using factorization machines as well. For all intents and purposes, you can treat them as I get an embedding, I can do dot product. Now, there are different variations of it. You can field aware, field weighted, low rank. This was published just last month at Rexis in Italy. Rexis is like top tier recommendation conference by ACM. My point being that there are different flavors of embedding models, of collaborative filtering models, of factorization models, and they all give you a vector. You can do a dot product, get the items, and that gives you the retrieval, right? So if you're working at a company doing field recommendations, today within a few hours you can get personalized recommendation out there by this retrieval. Now this is what people do, right? What other mature companies do is like, hey, I want to not just have a retriever, I want to have a two-stage setup. So two-stage setup says that I have a corpus of millions of items. Now, if I have a big model, I cannot rank millions of items within like 100, 500 milliseconds, right? So what I'm going to do is I'm going to bring in a candidate generator. The goal of the candidate generator is that, hey, I have a corpus of millions of items. My model cannot rank them. Give me a few hundreds. So this is like a lightweight ML model. It could be the embedding model we used previously. The role of the candidate generator is go from millions to a few hundreds. Now, if I have a few hundreds, then I can bring in my fancy ranking model, which is mixture of experts or your neural model. This is going to be a lot of additional features. Each item can be ranked in like, if you're using Selden, you can rank them in like 30 milliseconds. If you're using TensorFlow Serve, you're probably like 45 milliseconds, so you should use Selden. But essentially, like, you only get like limited latency budget, right? So you cannot rank millions, you only want to rank hundreds, so you have a candidate generator in between. And then you rank it and then kind of show it to the users, right? So this is from YouTube's Rexis 2016 paper. So essentially, right, this two-stage setup goes from tens of millions to a few hundreds, and then if you're Amazon or if you're Deliveroo is gonna do some re-ranking, right? I have my handshake with McDonald's, so I'm gonna show that McDonald's restaurant even though if you hit, right? So I will re-rank based on some business logic. So that's the typical pipeline of a two-stage setup. And people have done like crazy stuff with this, right? What are the two stages? One is the CG, the candidate generator, which goes from 100 millions to 100, and then the ranker, right? The ranker goes from 100 to top 10 to show to you. Now, in the CG candidate generators, people have used two-star models, factorization models, graph models, SVD-based, and also business-based, right? I get, let's say I'm Netflix, right? If I'm Netflix, I want to show Netflix originals to you. So that is revenue generating for me. So I'll have a candidate generator only recommending to the ranker that, hey, here is paid content, here's promoted content, right? So again, you can have many candidate generators. In the realm of rankers, what's state of the art today is mixture of experts. And if you've been following some LLMs as well, they're also getting trained on using some sort of like mixture of experts. What mixture of experts says is, I have this input, I have the output. Input is like user, comma, item, right? Will this user like this track? All of this is here. Output is like, what's the probability of user downloading this track, for example, or saving it? And in between, you have these like experts, and each expert is gonna have an opinion, and then they're gonna train themselves, right? So again, if you look at, this is a mixture of self model, this is similar. This is multi-task prediction. Will you like a song? Will you save it to your playlist? If you're saving a track to the playlist, that's great because you're going to listen to it afterwards as well. So again, you can make multiple predictions and you can have mixture experts in a multi-task setup as well. And this is a very similar architecture from Kuaishou. Kuaishou, how many of you know Kuaishou Sky? So it's one of the like what, 200 million daily active users product in China. So again, like really large scale machine learning, again, using mixture of experts model in Ranker. So there's this like, sorry. Yeah, so I think great question. The question from Janu is like, what are the experts doing, right? So again, these experts are intermediate representation. These are intermediate layers. So we really, I mean, again, we can't interpret what they are doing, but essentially, intuitively, the role they play is that some of these might capture like your local nuances. I mean, if you're talking about music, right? Maybe if I'm recommending podcasts to you and on a music and podcast app, then have you speak? I mean, what's the probability of your likiness towards certain traders? Do you like these genres? Do you not like these genres? So I think one, there is no scientific answer on like unless you do some interpretability work on like what these experts are capturing. But the intuition in general is that the mixture of each expert focuses on different types of understanding. I need to make the right recommendation, and then then you do a voting, right? That hey, maybe for a certain type of users, this expert really focuses on those users, right? Imagine you have like a lot of teenagers. Teenagers love discovery, and that's why Spotify at some point they were a lot moving towards TikTok, right? So Spotify and other platforms wanted to show more discovery. So again, if discovery is an important problem, then you need to make sure that some expert is focusing on discovery versus some expert is focusing more on familiar music. This is just a hand-wavy explanation.
So they don't have any objective.
Yeah, exactly. So these are just intermediate, right? So we don't. We can't. I'm just saying that I hope they focus on discovery, but I can't make them focus on discovery because this is just like internally within the model. Now this is like neural models. The other type of models which people have been using are reinforcement learning. Very simple approach is a bandit, which says that hey, if I show you a certain thing, do you like it or not? I can learn from that feedback, and then tomorrow I update. So this is like a bandit-based setting. Essentially, if you're building a ranker, a sophisticated ranker, you can either do a mixture of experts model like a deep neural models or a bandit, and they both offer different flavors. Essentially what that means is I want to learn an action distribution. Like imagine like the number of playlists, or if let's say I'm Deliveroo, right? And on Deliveroo I want to show restaurants. If I'm in London, Stratford, I have maybe 150 restaurants close enough. That's M is the space of 150 restaurants. Now pi becomes the policy that for this reward signal, for these 150, what restaurant should I pick and show to you on the top? So this is how a bandit works, right? It says that, hey, let's say, this is Spotify. Imagine like this is Deliveroo, this is like a Thai restaurant. What should the next restaurant be over here? So I have these restaurants. I picked up one, showed it. Remaining ones, I want to sample a card, sample a restaurant from this policy pie, and then add it and show to you. So that's how a bandit works, which says that, hey, I have a policy. I want to sample from the policy and show to you. Whether you order from it or not, I can update. Now, essentially, these are like two high-level approaches. And suddenly we've gone from a system which is just use dot product, between embeddings, pick the top K. Now I have a model which is learned. Right? So now the feedback loop is in the system. And now we have a two-stage setup. So now suddenly, if you're here, then you're in a very decently mature setup. And you won't believe how many companies are not here. A scarily large number of companies are not here. And again, this is a trend which we are seeing, which I'm seeing, and I want to try to fix it. The talk is not about fixing it. The talk is about just mentioning that this is a trend. Now again, very simply, right? What people do next is like they start thinking about, okay, cool. I have a model. I'm training that model. Now let's know what am I training it on the right objective? What is the label, right? So now I'm going to forget about all the math. Put all your product intuition around what should the reward signal be. And one example is like Spotify, for example. Put train. If I show you this track, if you stream for 30 seconds or more, +1, you liked it. If you did not stream for 30 seconds, you hated it, -1. That is the default. But then we realized that there's a lot of variation across playlists, like sleep music. If you only stream sleep music for 30 seconds, right? I want you to for 30 minutes, maybe 2 hours. I mean, 30 seconds is a bad label for sleep music. Same across listeners consume music a lot more longer than other listeners. I am not a jazz listener. I don't know. I don't relate with this. But essentially, right, there's a lot of heterogeneity across users in the net. Why do I have a fixed threshold? Like, why am I doing this? All users, all content 30 seconds. That's stupid. I would love to do each content, but I can't show that because 400 users, 100 million items. I can't show any of this. So let me do some focus thing. Like groups of users consume content. So again, Chrome was training 2003 was the first paper on this. The real is doing it at 100 million views. That's where like approximate SVDs and all the other stuff comes in. There are libraries for that. GPUs, I got talent for deploying all these also there. So now we can do like real large scale, and then user cluster, I cluster, how much you can, and what should the order be for you. And when I do that, I move metrics like that. Now I'm developing now understands your user group, your content consumption, and then decide what we say. Another example, if you look at YouTube, right? YouTube has short videos, like 30 to 40 seconds. It has 5-minute videos, it has 15-minute videos, it has all the sessions. This one is Now the question is, what signals should I optimize on YouTube? What signals should I optimize? Right? I mean, there's a lot of, and I want to successfully complete a video. Right? Now, what people would do is like, they want to define what is a successful video place. How do I know that you like this video? You completed enough. So the simple thing would be, I can do a fixed threshold. If you watch for 120 seconds, it's a plus one. Now, the problem is this is not going to work for longer videos. Because if it's a 2-hour video, if you only watch for 20 seconds, it's not going to be bad. For shorter videos, it's like, yeah, I mean, it's a bad signal. All I do was the database watch. If you complete like maybe 50% of the video, or maybe 90% of the video, then it's a plus one. But 90% of a 10-minute video is 9 minutes. Sure. 90% of like a 200-minute video is 20. I mean, it's like 180 minutes. Okay, so suddenly, if I have this label is going to give a lot of preference to shorter videos. It's not going to give a lot of preference to longer videos. Why? Because it's really hard to get to 90% of a long video. So suddenly, these tables are biased towards short videos. A lot of short videos have plus ones. Very few long videos have plus ones. Right? This is a problem because suddenly, now the ranker thinks that only short videos have plus one. Great, let me show short videos. And that's creating how the platform, right? So then you do some buzzers and diagrams and like. My point is, this function is a bunch of publishing questions from reads and from articles as well. That hey, I can't restrict my information, I have to know more about this and then define what values. Regardless of what model you use, regression model, regression, insurance, first mandate, whatever, just this thinking on that, I have to be careful on which signal to optimize for that model. Again, I'm going to skip the videos. The point is, if you have one destination, longer videos are preferred. If you have the other destination, shorter videos are preferred, and this creates havoc on your platform. It also creates havoc from a revenue perspective. Why? Because advertisers pay money for longer videos. Because if you are watching a 25-minute clip, you're at a 30-minute mark. If I show you an ad over there, you have invested as a user, you're going to complete the ad and not skip it. So if I'm an advertiser, I'm going to pay more money to be placed on a longer video. So you as a platform care about whether your consumption is more on short videos or long videos because you're going to earn or lose money accordingly. So this is all the motivation. Look, you have to care about what is my platform level distribution. Is it more short? Is it more long? I want to control it so that I need to pay attention to what my signal is. Taking a step back, right? Where are we? We said that now think about like how many companies get to this stage. And are you thinking about this is just data science, right? There's no fancy math, nothing. The model is already deployed and sell it. It's just that what is the label? Am I spending enough attention and brain science to think about the actual signal over there? And finally, look, Deliveroo is, I love Deliveroo. I'm a pro, premium, whatever customer, but it's not just about user. Are you showing enough restaurants as well? Right? I mean, if I have a Thai restaurant, you never show me to users, I don't get money from you. If I'm a driver, delivery partner on Deliveroo, if I mean, the other delivery partner gets a lot of rides, I'm just sitting idle at Stratford and like waiting for a ride. So the problem is these platforms are multi-objective. They have to care not just about the user, but also about the restaurants and the delivery partners, and also they have to survive, right? They never make money. So if I have a deal with McDonald's, I have to show McDonald's enough. And I'm probably committed, like, McDonald's, I'm going to give you at least 10,000 customers a day. So I have to fulfill those obligations. Point being, this is a multi-objective setup, right? It's not just the user, there's a lot of delivery partners, a lot of like other platforms, economics of the platform itself. This is a multi-objective problem, which needs a multi-objective function. The label which I was talking about so far was single objective. Now let's make it multi-objective. We won't have time to go into how we make it multi-objective. View. So trust me, there's a paper on this, and the paper basically said, mandates, replace it by multi-objective function. A really, really hand-wavy math. You take from the rich, give it to the poor, it's a bit more balanced. So this function does a lot of balancing. It says that, hey, how my object is doing, this is great, these are not great. If we take something here, give it here, this becomes a bit more balanced, and a function optimizes for that. And you put it in the bandwidth, it's a bit more balanced. So again, what's my point? My point is, now I've done like one year of balancing. And people do that, right? I mean, this is something even a very simple startup would do. How they would do is like, you get the ranking, and will insert the promotion randomly and like technology. Because this is an easy thing, they're not going to wait for the LLM to answer, right? I'm going to do it. I'm a product owner, I'm a product manager. I want to make money from showing more ads or from showing promoted content. I don't care about user engagement loss. I'll just show it on slot 3, slot 5, slot 7 because I can. So again, product won't wait for ML to catch up, right? I mean, they will start showing this, but as ML engineers, you want to walk your way to this setup so that you can have a principal solution. Finally, it's about the biggest point I love, which is systems. This is not an ML model, it's about the entire system. And again, I'm preaching to over here. Systems mean that it's not just about balancing, showing the field and evaluation. Right? It's about spending time understanding the users, user expectation, user discovery propensity, user consumption diet, all of these things. Big companies have entire teams. I was talking with somebody from Anna, 60 engineers, 10 ML engineers, right? And there are teams at big companies which are 30 ML engineers only on using discovery consumption. So that's the discrepancy between a small company and a big company. Big company have like hundreds of people just focus on this one role. Now the problem is, look, I want to be doing the same as well, and today the tools don't allow me to do that. I can't afford to spend 20 people just to think about user discovery and user familiarity, because big companies have 1,000 engineers. Today, smaller companies do it. But then my point is, it's a lot of thinking around all of these, and then a lot of thinking about intent. What is my intent when I open the app? There's a prediction being made over there. It's called in-session personalization. Like, what are my recent dissatisfaction signals I learn from this? It's about feedback loops. It's about reward models. It's about adaptive decisioning measurement. So this is a world of 100 predictions. You open a good mature app, it's going to make 25 predictions in the 800 millisecond first, and then it's going to show you content. This is where most of these mature products are. And this is why it takes, sorry, I don't know why it's here, but this is cool. Like, maybe it's a better pick. But yeah, so again, my point is like, this is a system which people are building. And each of these systems are ML models, maybe a bunch of ML models within these boxes, and that's the maturity of like a big established recommendation product. And this is a journey, right? Often it takes like 10, 15, 20 years, not 20 years, maybe like 5 years, maybe like 7 years. And like it takes like ML teams to scale from like 0 to maybe 50, 60, 100-ish to get to these. Right? So I think that's where the current status is. I'm just saying that this doesn't look good to me. I don't have a solution today, but yeah, I mean, I would love, this is your realization as well, I would love to go in comments. I don't know why I said comments for the audiences, but like after the talk. Let's come back to the RAG part. Right? So this is what's been happening in the last 15 years in the industry. And this is not just recommendation, this is search recommendation score. And again, arguably, right, recommendations is the biggest, up until ChatGPT, probably is the biggest revenue earning in the industry company, ads and recommendations, because that's where the trillions of billions of dollars of revenue get spent and earned. So I would say that if you're a machine learning enthusiast, then recommendations is the place in the industry which earns companies the shittiest amount of money, right? Ads and recommendations. So these are like really, really important problems from a revenue perspective. Let me bring it back to RAG. And it's going to be the exact same replication story. The takeaway message, if you want to close off for the next 5 minutes, is if you spend 15, 20 years as an industry to do all of this in indexes, why are we being so stupid in RAG? And that's the entire message. Right? In RAG, the problem is like, again, I was working with Cody, big code problem, like getting coding copilot essentially. Again, not about it. The point is, any RAG system you're building, which needs LLM to have good context about the code base or the documentation or whatever, it needs to do search for the right fit. Right? So given a query, I need to fetch relevant code snippets or relevant documents, whatever. And again, if I find this function that intent detector, then I need to use this detector, another file in another folder, maybe another repository. I need to search and add it so that I can do a good code completion here. So that's the importance of context. Right? So essentially what typically comes to do, this is called a SCODI, this is like any coding assistant, coding copilot, any copilot you've been using. For a query, they will bring in one time, and then the LLM will give you almost correct response, right? Otherwise, it's just hallucinate. And the point is, like, for this query, it fetches these chunks. Like, in user.py, it fetches these lines, and readme, it fetches these lines. Now, this is similar to, this is what context is, right? And the code base has these context items. Now, the question is, I don't know, like, which ones are relevant and which ones aren't. And this is similar to the recommendation problem. Like, I have a massive item base, 100 million user files. Here, I have 100 million code files, for example. Now, for a query, for you come to Spotify, I fetch items. Right? You come to ask a question, I fetch items. Now, the problem is, I don't have these relevant tables. So, today's system is like this. Today's like a RAG system today is, I have my code base or documents, I read it, fetch it, I do the prompt, send it to the other. This is a single stage setup. Again, reminiscent of my single retriever and the recommendation side. Right? Embedding is the context source, only one retriever, no ranker, no learning, no feedback. This is where most of the RAG applications are today. But we've seen this before. You need to run multi-stage files. Why? Because it's supposed to multi-stage. That makes sense. So let's talk about retrievers. Local files, keyword search, one vector embedding, graph-based search, whatever. It could be like multiple retrievers, as long as the retrievers are bringing in different perspectives. That's important. Why? Because Spotify or TikTok, they will have a retriever which brings in your local artist or your local niche taste, right? And that's a different problem. That's different from money making. That's different from others. So as long as they're bringing different, if you get the overlap analysis of what items is this bringing and this is not bringing, if that overlap is low, that's great. If the overlap is high, I don't need. I'm already getting 80% scale as well. So if you're adding more people, you need them to bring in a very different perspective. So that the Wrangler kind of thing, oh great, I mean, this is new. So again, let's add two context sources, one, and then let's add the Wrangler. Because the moment you have these context sources, you don't know which ones, you always have a limited budget in LLM. The context windows may be 120K, maybe a million, or maybe 10 million. But as and when you start to more context in the LLM, the attention sources start kind of wavering, and you don't pay attention. So that's why you need like a good top X to be stuff. And that's why we see this role. This is being the recommendation problem. Let's add another. And then it's not, it's not just for context sources. I should be looking at documentation. I should be looking at GIS. I should be looking at any number of other items. How can you do Glean as a startup? So Glean does enterprise search. Glean looks, Glean, there's many examples like that. But Glean does that here. If you are in a big company, 5,000 employees, you know, like n number of data sources where the content is, I'm going to index it all and then use it. So they're probably doing a lot of this. What's my point? The point is, this is heterogeneous items. So my writer should consume not just text, not just short videos, it should consume a lot of code, a lot of other pieces of metadata as well. This is all in the industry. If you look at TikTok, or if you look at WeChat in China, so a lot of these China applications have news articles, have apps. I mean, that feed is like very heterogeneous. It's not just short videos, applications, articles, and everything. So they've been around for years now, and they've been building a lot of classes. So again, there are applications which have been developing really multi-model recommendation systems for the last decade or so. And this is no problem again. I'm going to tell you one problem I mentioned. If I'm a Spotify, if I'm a Lexis company, right? If I candidate generates select few items, the ranker picks it up. It shows to you either skip it or not. I get to know whether this was the correct decision or not. Here, my problem is, I don't show these items to you. I feed it to the LLM. The LLM gives the response. So I never get these results. That's the biggest problem. The biggest problem is, when I bring in context, it gets eaten by the LLM. The LLM generates the response. It may be correct or not. But then the LLM is not telling me that they go right or wrong. The LLM is not telling me they go right or wrong. So on each item, I don't get it at all. And that's the biggest problem, transitioning from the Lexis to this. I don't have relevance to this over here. So how do I create that noise? In the next world, I have elements because I showed them to you. You can save it, you can skip it, you can download it, or not. Right? I don't have that here, that's not problem. The solution is not also this talk, but you can do something specific. The other problem is evaluation. Right? Evaluation is like, this is again, it's a process, LLM evaluation. This is a pipeline, right? You use query processing, you check the context, translate it, send it to the LLM, make the LLM call, LLM generated response, then you process that. That's a typical pipeline of any LLM. The evaluation is like, how well is this context working? When is this working? Keyword search, given is working, graph context is working. That's not an evaluation question. How well are you ranking the context items? How well is the prompt round? Because some LLMs pay attention to the top, some pay attention to the bottom, some pay attention differently. So again, different language models have different attention mechanisms and they spread across the. So again, how is my prompt overall behaving? And how is my overall context engine behaving? And how is my overall LLM algorithm? Now, all of these are like evaluation problems in and of itself. And these need a lot of, I think, development will actually build and actually have these built for evaluation. And most of these companies don't have it. So these are the evaluation problems. In the last 5 minutes, summary, right? We talked about recommendations 10, 15 years. Today, a lot of companies today, even if they're like Series A-ish, they still would use feed, retriever, classification, forcefully, and then they're going to take time to evolve, right? Recommendations is evolve. Properly conversation, one way or the other will be evolving a similar list. And if you're taking steps, you definitely should copy paste a lot of these like architectures and you'll be happy with that. Now my point is, in the last 5 minutes, this is not just here. Any problem you make up, ad load balancing, there's somebody from Apple Pay with. Yeah. So Apple Pay is another example. And one other problem at Apple Pay would be that how much cashback should I give you? Right? Should I give you 5% cashback? If I give you 5% cashback, then maybe you're going to be maybe you would have used 3% cashback. Then why am I paying 2%? Maybe some other person will not come and try, they will come and try. Now this is the important problem. I'm losing money every day. If I give everybody 5% cashback, some users would have gone back anyway without even using cashback. Some people might have taken longer, some people might have taken shorter. So this is another one of these forms of like balancing, right? Ad load balancing, how many ads do I show? If I show more ads, I get more money. But then you disappear. You like, hey, this is a lot of ads. I'm going to stop using it. So I lose you, user getting. If I show less ads, you retain more on the platform, but I make less money. So this is the balancing problem. So again, there's a bunch of these problems wherein the same problem exists. In the last 3 minutes, what I'm going to do is, again, this is probably the second time I'm showing this. So huge disclaimer. I may not know what I'm talking about, but what I want to do is like really try to map like what companies are doing across these problem statements and at what stage, right? And then try to again why to this audience because it's probably the MLOps to see it not going to be maturing as a company goes. But at least from me, from an ML perspective, I want to get some validation of like, hey, is the maturity of your ML systems evolving as you evolve as a company? Right? So what I'm going to do is, again, x-axis is time, scale, y-axis is like company making money, raising money, whatever. So this is it's not like seed station. I'm not talking about 2-3 problems. One is what are you doing in the recommendation? What are you doing for like 5% cashback discounts? And what are you doing in evaluations? These are the 3 problems you're going to talk about. If you're a seed stage and you probably have a single retriever, you're probably doing something mistake. Let's just give 5% discount to everyone. And I still manually data set evaluate. If I'm a bit more mature, and I have multiple retrievers, I have a personalized user. It's not an ML model. I look at that, yeah, man, if you've been using Apple Pay for the last 7 days, then I don't need to give you this, I'm going to use it. So then this is a personalized policy. It's a heuristic. It's not an ML model, I'm just looking at some heuristics. And my evaluation is like, yeah, maybe I have some metrics to measure what's going on. Maybe I have some users to maybe test. I'm a Series A, I don't have 100 million users. I only have 10,000 users. Maybe I can do statistic testing, maybe not. As and when I'm sure, in the recommendation side, I can do some 2-stage ranking and have some objectives, think about them deeply. Right? Now I can predict for the Apple playground. I can predict that, hey, when you come back, would you use Apple if I give you 7.5%? Would you come back if I give you 6%? I can start making these predictions. And recommendations start getting more and more. Like discovery, diversity, you get enough consumption time. And you fulfilling your needs. So I can afford to think about these things. If I have a series A before, I don't care about this. I got discovery. Right? Discovery, all things like I can't afford to care about it. As you mentioned, now starting on Google, let's mature. I think about analytics, let's more data as well. Because if I give you more discount, you're going to come back, I use it. If I give you less discount, you don't come back, I say money. So okay, that's a balancing problem. How many of you know counterfactual evaluation? Have you ever heard of the phrase counterfactual evaluation? Few people, right? Counterfactual, that's the point, right? Counterfactual evaluation is offline online correlation, mature experimentation companies care a lot about is my evaluation even happening? If I move this way, is the user actually going to be happy? Am I actually going to make money? So this entire area is dedicated to counterfactual evaluation. And there's times where like very senior ML people want to talk about counterfactual evaluation because we take up because I don't even have this. Like I can't really be thinking about counterfactual evaluation. I want to develop, but it's not thinking about it to do that. And then finally, the company, you can be the recommendation among these. I mean, I get to talk at these fair workshops, and I want to convey the point. I've been in a company which really struggled between the 2020 after the where I ended. There, I can't afford to think about societal impact if my company has to survive and make money. So again, the point is all these long-term impacts and societal impact, all of these important, but then enterprise setup means I'd like to find a Series B company. I cannot afford to care about that, right? And I cannot afford to care about the straight off of solution. This is a solution that LinkedIn today. If you use LinkedIn feed,
I'm going to do something which I didn't plan on doing, but just here is
privacy optimization, which is in production at LinkedIn. It says that this foundation maximizes revenue across all information so that total engagement doesn't constant value. So this is LinkedIn's optimization of how are they doing as visitor optimization solution. And this is like a really getting around this topic.
so again, I think like at the end I'm just going to conclude by saying
that take home messages. Recommendation populations, we spent the last 3 years as an industry. We go from triggers to 2-stage, think about rewards, think about what you can and so on. The probably should be, we are starting the same year interacts, going from single reviewers to 2-stage, evaluation is a nightmare, feedback is a nightmare because I don't get the mistakes. And these are all the and companies such as their foundations such as scale, and probably the other I mean, this is, let's not get us, this is like a force away from you to get back to the community. Then probably the tools which I have been bought, the tools which you guys have been bought, probably need to scale as these foundations mature as well.
and a bunch of papers we can talk about later.
Maybe you are maybe also these issues of giving a solution that actually simple and more not more like say and data see a lot of accounts that being chosen by training on that, overfitting to that.
I love the question. The question is that, hey, I don't know what you're balancing how to do this, but then I will be catching up. Right? I mean, like, I have to make it money before, so I so even if I've never shown this company to you, so what do I train? How do I get that? And that's a very valid point. Even if you want to do a better job, you data doesn't support that. Now, this is where like we need forward thinking. That's the entire purpose of the talk. If you are here in any of the spaces, keep this in mind. Because when you keep this in mind, you're going to do logging, you're going to do randomized data collection. For example, one person traffic, I'm going to randomly show you random restaurants. Again, I'm going to cap each of your only is like a section of random recommendations. But then if one person of my traffic is randomized, at least then sometimes I've shown discovery, new items, sometimes I've shown the restaurants from OHP. Right? At least the data is like very, very low volume. And then we have our manufacturing areas to get some good ratings around. But then at least some ability based on that randomized data which is there. Doesn't have to be you gotta get it not from the model, but also data and you will also have all the elements. Look, if I want to be a learner, then is my inferencing faster? If I want to have more features, then my users are using the code because whatever. And my latency tick from again the models can I mean that won't work with you, right? So the point is like this is giving you a lens of like where things are probably getting, regardless of where you are currently situated. But if you envision that there was going to be some different months, then you're going to be starting on the MLOps side of things, like what does it what needs to have. But this is where like a very is not only like it's a problem. I know I have to do data understanding, but I don't have to get data science. So why should I use data science? That's a lot of work. I get zero value. Right? So that's why a lot of these don't really try to do. I think there's a fixing two real-time features and use them in some model. Don't build real-time models. Have some real-time signals, and then use that to inform some recommendation policy. That like if you have skipped in the last 10 minutes, I'm not going to show you. That doesn't mean I'm not. That just shows the power of real-time analytics. And if that evidence gives you, then you motivate the need for that feature. You ship that feature because it's giving you a gain. Tomorrow, when an MLP comes in, they're going to say, oh, great, this good feature exists. Now I can do it. Right? So basically, you can handhold the features, ship them on a good state, and then slowly bring it to a very simple production model, and then advance to go plan that in another. Right? So basically, handhold your chickens and kids along the way. The first one.
You said that feedback of the context.
Yeah.
It's not observing before. Do you have a very short summary of potential ways to solve it?
Yeah, I mean, I have some answers which are scientific architect. So the question is, we know that this is a problem and we'll get a solution. So again, there's a few approaches which we define as driven. I feel like, well, if I look at the LLM got the answer wrong, I won't care about what the LLM is. If the LLM got the answer right, then maybe I can think about where is the LLM paying attention to. And if the LLM is paying attention to this item, and the LLM got the answer right, then it is correct. So the question is, from that we started getting some preference data set. So if I give the LLM like 25 context items, the LLM got the answer right. I pick up the items the LLM gives max attention to and the least attention to. And maybe I can have a preference judgment that this is more relevant than this. So that that sounds like a very good English motivation, intuition. We find that with the models didn't work. So I don't know, like we haven't investigated by the other thing we did was we flipped it. We said that look, I'll create a question from I'm going to pick up the context item, create a question on that, throw this away, and then ask it. Essentially, what that means is I'm creating my graph of relevance context because I'm generating the question from the vector. So imagine like you have a repository, I go to this function, I create a question I generate a question on this function, and then I just take a question. Ground truth, I know what right file has this. Now let me pass it to my context and see that I can pick it up. Another clever thing which we did was I did not GitHub code file, GitHub comments file. If you're sending a GitHub PR, then your comment message is a query, and the files which you edited were relevant items. Because if this is a comment message, then the files which you edited have to be relevant items. So again, these are some clever ways in which we try to get to some ground of data. Now this is one of the things that I do, right? If I'm working in code, I can get loss, PR loss. If you're working on some other problems, you may or may not get it. So some of these are generalized, some of these are not. So yeah, these are the three approach, and one didn't work. There's a question.
Very recently we spoke about some of the labeling strategies, different labeling strategies by the users. And you also mentioned that a lot of companies are not going on a certain stage in that recommendations stage that you spoke about. I think you just think about what are the problems why certain companies aren't going beyond that. So if there are any more problems why companies aren't going beyond that stage, I'd love to know more, and as well as your solutions for that. Is it just about having more experts or more sophisticated answer systems, or are there other solutions?
Another question. How many people actually agree with this talk's thesis? That look, I mean, okay, the question is, hey, I mean, if there was a problem, why aren't people exploring here? And two, then what's the solution? Right? So to preface this all, like, let me quick poll of curious panelists. How many of you do agree with this? That hey, companies are a problem. Wow, this is so big. Again, I'll repeat the question. If you've been sleeping in the last 5 minutes, the question is, what I'm proposing here in the talk is that there's a maturity stage. Most of these big companies, hundreds of engineers, great engineers, big product, are submitted. Why aren't more companies? Again, that's the question. The point I'm proposing is that there are different stages, and as when you make your product better, your systems better, you plan somewhere over here, and these systems are like far better, you make far more money, you use far more applicants. So that's the basic point. How many of you agree with this? Great. So question the population size. Yeah, so now the question is like the question, so okay, so the question is like, why is this happening? What's the reason? Now I would love to know the answer to why this is happening, but my hypothesis is one, you don't know what you're doing. Because I mean, this MLEs are like, I mean, all these great software engineers across any domain are like really hard to find. If you, I mean, I looked at this just 2 days ago, that's I know. On levels.fyi, the average median salary in the US, in the Bay Area, is 400-500 KBC for a senior level engineer. What that means is there's a supply-demand relationship over here. It's very hard. Okay, I'll give you some examples in London. There's a startup in London which told me that I can hire a junior level talent, but they just know how to solve this one problem. They can't think of it. If I hire a senior person, they want to be managers. They can't code, but they don't want to. So the problem is people who know a lot more. They probably have that. People who know they probably don't have enough context, which is fair, right? If you've seen the journey of something that you would know, otherwise you won't know that these things exist unless you go to conferences or whatever, unless you can meet us. So again, I think that's a problem which is very valid. Junior talent, there's no junior talent, less experienced talent in this industry won't know all of this. No experienced talent won't know what we have. So I mean, these are some of the, and also things like it's investment, right? Like the amount of investment of data. One, I don't have the data. Two, I don't have my engineering systems. My engineering systems are very broken, even today without using pressures. And now if you want me to make it real time, I'm with the engineers, it's going to take like 6 months, and I'm going to get 0 memory gains in these 6 months. It may or may not work, and may or may not even have the right engineers in my team to put it on. At one of these companies, Spotify, we wanted to do GraphML. I just said I won't do GraphML because I don't know as a staff engineer from Pinterest to do this. I know the solution is the right solution, but then Pinterest engineers have experience developing graphs of 500 million plus nodes. My engineers don't have that experience. So I know the kind of challenges it face, and I don't know the hiring budget to hire that engineer, and I do not know that. So again, these are the systems, all of these are like limitations. These are the problems. Solutions, I think, I probably won't comment like what the solutions are, because I don't know what I'm talking about. But I feel like there are some systems which can be leapfrogged. We directly went, I mean, I'll give you my example. As far as we went to the one solution, which was a non-learned solution, which worked great, and that motivated a lot of engineering work for the next 10 years at least. Right? You get to, if you're smart and you get to like prove that this works, we ship the heuristic, and then build the ML models and the engineering systems around that. So I think like there are these other ways to jump from and then like go back and like and probably
something like these today, I don't know, like I don't know what like I maybe that's a motivation for something essentially that's
Right. Yes, I mean that's a motivation is great, but also like if you're not in rags, most of these rags 1 year ago were not, they were new, and then you go and look beyond. Hey, I mean, what again? The point is like the rag systems are comprising the metric systems. So if you haven't seen rag systems before, take a step back and look out there are systems being built as well. So there's a lot which kind of runs these as well.
The factor is, even the analytics, the market itself doesn't have the volume to support it. I think that's
Yeah, the product, yeah, the business, yeah.
there's no market.
Exactly. I love it, right? Exactly. That's why the point was like all the market was relevant. Right? I mean, again, like, if you are able to formulate, motivate one of these from like, hey, if I do this, I can do, you can make more money. That's the easiest way. Unfortunately, that's the easiest way. Yeah. Right. And then I think like the point is like plateauing. The point of plateauing is great because that makes me sense, right? Look, at Spotify, one of my proposals by the time I left was like, if you have 25% discovery appetite, then in that discovery appetite, I can show you some promoted content because you're open to discovery. Now, that's a good ML system. But a better ML system is how do I make that 25%, 30% in the next 6 months? So yeah, go meta, right? I know your discovery appetite, but then can I increase your discovery appetite month by month so that I'm generating my revenue potential for the next 1 year, right? So I think it's about formulating it as a meta problem and then like thinking slightly long term and then consumption shaping you to be consuming more discovery so that 1 year down the line you can consume 4 more paid content so that I can get 4 more cents on that, right?
Regarding the context problem, in fact, how the market cycles might not be relevant. This first. So one of the things that I think a friend of is now building another agent who's just responsible for verifying what is the ranking of each of these contexts, and then removing the ones which do not make so that the ranking low.
Right. Yeah, great point. Yeah, great point. It's like if you don't know what's right, then once, so we can also go back and so we can also have an LLM judge. The LLM judge, right? And the LLM judge exactly fine-tune on hey, do you identify with this or not? And I think that's also great to share feedback loop as well. That hey, we did wrong and then they find it. So essentially that means that there's a learning process in that module itself. The judge just runs around. Right. Yeah. But yeah, so there's a question.
So you mentioned graphs. I'm wondering if you go back to the evolution technique. Where do you say that graphs are things?
Yeah, so I think that's a good question. So I think the way Pinterest uses, Pinterest is my favorite example because Pinterest has this like pins and boards and like building scale graphs before a lot of other things. And they use graphs as a review. So again, the point is just because they use it as a reviewer doesn't mean that's their first solution. So again, you can a lot of companies will still do state-of-the-art innovation right at the reviewers. Because if you're able to exactly. Yeah. So I think what they did was like the graph basing meditation from the papers. I mean, there's actually a startup, AI as well, out of like same group, right? Same group, which did all of this startup around like last year of machine learning. And essentially, it's like you embed these huge pins and boards in like within no graph, learn these embeddings, using local linear and all, and then slowly learn. Once the embeddings are stored, then it's no different than my word web model or my FM model or whatever. It's just the database exists for the embeddings, you just put them out. So the other example is like kind of a closed graph, you will do like code graph, like your dependencies graph. So graphs could be instantiated using a lot of different data, right? Your codependencies, your stack dependencies, and that will be the code graph. So again, like we added them after going into the learning. So we added another people graph. I mean, the first video probably is in graphs if you graphs with you. But then you spend months just teaching it like how to deploy these like huge graphs and that.
But then it's going in graph. As you said, you can just graph.
Yeah, but then like if the learning on that graph, again, it depends on the number of nodes. If it's a billion node model, then you have to do the training on that. And then the thing is that if fresh is the problem, then for fresh content, I don't want to use that. Because if I'm somebody else, I get 100 million items a month, that means I get like 2 million a day, more or less. So my graph is like so dynamic that it's a lot of plastic.
Do you think there's more to use like in personal fine-tune the language models in academia or in industry? Because we're even if we're like physics, software design, just
So is the question that like, do you think that LLMs will finally
fine-tune?
yeah, oh, well, I mean that's a very valid. I mean I want to do that in previous job. Why? Because I really have unit generation. Right? Well, like if I'm building code, if I if you go and start using a new code base and you are asking like question like what does this function do? Now what is the right response answer for the question? It's like is it like hey this function does this or the answer is like hey this function does this, it's one of these functions and situate within the code base this answer for you. Right? So if you can give that as a good staff engineer would situate it like, you know what, here is what was 4 plus, here is what was more plus, now within this, here is what is something. This response is much better than the first one. The only way to make the LLMs learn this is by LLMs. Why? Because I need for this onboarding question, here's the new philosophy, here's the question what is to, here is a less good response, here's a much better response. And I'll just give a quick this is better than this. That's the most easiest way for me to get coding or get a project to generate these responses. So my point is, I mean, RLHF for industry in these applications are the one of the most important cases. The point is like we need to make that. Because to make chat work, I was focusing more on context engine, and that will be like context engine, and then you do that thing because I just want to make sure that at least the hallucinations are less and the chat response quality is good. Once it's good, then I can focus on like, hey, what's even better. So I think that's what I'm doing. Sure. So what is it? Oh, no, so I'm not. I mean, I haven't used RLHF question. I mean, I have read it. References. Yeah. So I mean, anything I say is not from personal experience. I'd rather not say that because I mean, what I have read on Reddit is talking about like you or whatever.
So the approach it's about like what we call building for context and nowadays insurance supports functional. So is it possible to build the context more interactive and interactive with it?
Exactly right. I mean, the question is, I love the question. That's the one. Look, it's like function calls. Function calls means that like, hey, for this query, what function should I be using? How is it different than anything? Okay, it's a probably question. The point is that if you give me a query, for this, what are the right use cases? What tools do I have? Maybe I have a use case. There are 12 functions. For this query, which function will solve this problem? It's probably like this multi-class classification, or like, hey, for this is what we use. And that multi-class classification is similar to anything. Do you want to consume this? Do you want to consume podcast? Do you want to consume old, new? The moment you open the app, I know you get one, like make a prediction, and then the feed is according to it. In the LLM, I get the query. Is this query about unit generation? Is it about like documentation? Is it about something else? If it's about unit generation, I'll route it to that LLM which does unit generation, or which is a function tool which actually is useful on that. So that's like routing, dynamic routing. Today, dynamic routing, there's a few startups which have raised good money on routing to the cheapest LLM. They're like, hey, this is query can be solved by a small LLM, so why waste money on the bigger LLM? So they're doing this routing much more cost. Your point is like you do routing, dynamic routing based on tools, based on the function, based on intent, which is what you should be doing, and this is also what like Lexis Stack says. Great. Okay.
Great, thank you. Someone's worked on recommendation systems about 10 years ago, and it's just incredible to see, how far things have progressed, especially now overlaying LLMs. So thank you, Rishabh, really excellent talk. I learned a lot, and I'm sure the rest of the group did as well. So that wraps up our MLOps London. Thanks to all of you for joining us this evening. It's been a pleasure hosting you here. We'll be reaching out afterwards, and we're always open to the feedback on how we can improve the event. And for speakers, so if you have anything interesting that you're working on, or know someone that you want to send in our direction, we'd love to hear from you, from them, and any other ideas about the event. We'll wrap up there. We'll give a few more minutes to socialize and network, and I hope to see you again soon in the new year. I think it's January, is that next one? Yeah. Have a great holiday. Cheers.